In this, we are going to learn what we call the factor theorem. So what it says, it says that if a equal to 0, then x minus a is a factor of fx. Very simple but very powerful. So it says that if fa equals 0, then x minus a is a factor. Remember the way we write x minus a. So that means you can factor fx like this. So you can pull out x minus a, and then we have another, this was the quotient. So the quotient is gx. So it is degree 1 less than the fx because you pull x minus a out. So this like works not necessarily for polynomials, like even for other functions. Good. So so this is one version. There's another version that now sometimes we call the remainder theorem. So let's also write that. So what that says, but this is the factor theorem, okay? This is the second one, the remainder theorem. So it says that if a is the remainder, when fx is divided by x minus a. That is, in other words, we can write fx like this. So that means we have x minus a factor, and then we have the quotient part plus the remainder is simply fa. That's going to be the remainder. But what happened if the remainder is 0 in the previous case, the fa is going to be 0, so that's gone. Then you have a factor. So it's like they are kind of connected to each other. So those are useful, but especially the first one is very useful when you want to find the factors. So let's write a note. So what we normally do is we use the rational roots theorem first. From the rational roots theorem, we find the possible values, and then we're going to plug in those values and see whether they are zeros. So that's what we normally do. So there are two things. We're going to try the values like 0, plus or minus 1, and plus or minus 2, like that. So even like plus or minus 1/2. Those are kind of possibilities. And then also the rational roots theorem. You can look at the other video for that. Rational roots theorem gives possible values for rational roots. It's only like rational roots. So that you can try. So that's a rational roots theorem. So this they go like hand in hand. We use a rational roots theorem plus the factor theorem if we want to find factors. Let's look at just one example how it works. So the example, so let's say use the factor theorem. To solve, let's say to solve a problem like this, to solve 2x cubed plus 3x squared minus 3x minus 3 equals 0. So what we normally do is if we get a problem, so it's a cubic equation. So the answer, so we're going to say let fx equal, we're going to pick the polynomial here, 2x3 plus 3x squared minus 2x minus 3. So let's plug in those common values first. So we always try 0 plus or minus 1. Okay, so let's plug in 0. So you plug in 0, and you can see that you get 0 plus 0 plus 0 minus 3, which is minus 3, not equal to 0. That means x minus 0. That means x is not a factor. So we don't do anything with that. So let's go to the next one. Let's do f1. So let's plug in 1. When you plug in 1, it is 2. 1 cube plus 3 1 squared. Some steps are not necessary, but I'm writing everything because this is the first example. Minus 3. So you're going to get 2 plus 3 minus 2 minus 3. You can see that it is 0. So that means factor theorem says that x minus 1 is a factor. So that means this implies that the factor theorem implies that x minus 1 is a factor. So let's try more. How about negative 1 as well? This is always a good option to check whether these are the case. So 2 negative 1 cube, and then we have 3 negative 1 squared, negative 2 negative 1 negative 3. So if you simplify, you get 2 times negative 1 here, plus this is always positive, so 3, and then plus 2 minus 3, and then you can see that this is 0. So that means, so this implies that x minus minus 1, in other words x plus 1, is a factor. So that's what the factor theorem says. So we already found two factors. We have x minus 1, x plus 1. We only need one more. So what we can do is we can use the log division or the synthetic division to find the other factor. Okay, so use log division, or synthetic division to find the other factor, So let's see how it's gonna work. So let's see how it works. So we're gonna put the coefficient first. So we're gonna use synthetic division. So use synthetic division. So we're gonna put the coefficients, only the coefficients, 2, 3, negative 2, negative 3. If something is missing, if a term 1 degree is missing, you have to make sure that you're going to include a 0 for that, otherwise you don't get the answer properly. So let's divide, see 1 is a factor, we already know, but we need to find the other one. So what we're going to do, we're going to put 1 here. So you're going to get, so we're going to copy that down to 2, and then 2, you're going to get 5, you multiply and add. So you're going to multiply by 5. So first what we do is multiply. You're going to multiply, and then you're going to add that there. Multiplication and addition. So keep doing it. So we're going to multiply 5 and add it here. So you're going to get 3, and multiply and add, you get 0. So if you get 0, that means it's completely factor. So this means that x minus 1 is always the opposite one. X minus 1 is a factor that we already know, but the goal is to find the other one. So now we're going to use the new answer for that. So we're going to go with the negative 1. We already know that that's also a factor. So put it here. So it is 2. And then multiply and add. Okay, so 3, multiply and add. So you get 0. That means x plus 1 is a factor. And the benefit is you find the last one, the other one. It says that 2, 3. That means it is 2x plus 3. So that's how we can use the factor theorem and the synthetic division to find the other factors, or completely factor. So that means that we can write the complete factorization now. So it is 2x cubed plus 3x squared minus 2x minus 3. Now you may wonder why we use a factor theorem, but factor theorem guarantees that it's all completely solved. So that's the one, because otherwise, like if you try to put 2 here, it doesn't work. So but factor theorem guarantees that you get 0, but there's no other way to find the last one, so you have to divide somehow. Or since this is cubic, if you find only one solution, you can find the other one by log division. Then you get a quadratic equation. Then you solve the quadratic equation to find the other two. That's the other way to do it. So there are a lot of ways to do the same problem. So now we know the factors. So it is x minus 1, x plus 1, and then the last one is 2x plus 3. That's coming from here. And now what we're going to do, we're going to set this equal to equal. We have to solve this. So we can set it equal to 0. And then we have x minus 1 equals 0, or x plus 1 equals 0, or 2x plus 3 equals 0. And this says that x equal 1 or negative 1, or how to get the last one? You move the 3 to the other side, so it's going negative 3 divided by 2 is going negative 3 halves. So those are the 3 solutions. So you solve the cubic.